So arc lengths and polar coordinates can be defined using parametric arc length formula. And parametric arc length formula was given as derivative squared plus derivative squared inside of the gigantic square root. So we will be using the same idea, just in this case, x and y are given their fixed formulas, r cosine and r sine. So we can find derivative this way. You will have, if you factor out r, blah, 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 simplify, eventually, that's what it says, eventually, we get this formula. And unfortunately, we're not going to give you this formula on a test. Instead, we're going to ask you to find arc lengths and polar. So you need to know this formula. Gigantic square root r squared plus derivative r squared. That's the difference. And we're going to do an example on that. Examples are not very complicated. I think the complicated part is actually remember the formula. So what I remember is, so again, we have r equals a function of theta. Angle is the input, r is the output. So we have original squared plus derivative squared. That's how I remember it, at least. Original squared plus derivative squared. While in parametric, it was derivative squared plus derivative squared. This formula comes from parametric, but it's factored out, simplified, blah, blah, blah. Let's practice the example. That's from your homework. Find the exact length of polar curve. Polar curve, not popular curve, I just realized. R equals 3 sine theta for theta from 0 to pi over 3. They should be both less or equal. So different way to say the same thing on a test and in your homework, don't get confused. Lengths of the arc, arc lengths, lengths of the curve, that's the same thing. Arc lengths is my favorite way to say it because it's fast. But actually, whatever is the length of the rope from here to here, that is arc length, length of the curve. Or the snake, right? Remember this, that's how I like to explain it. That's the same thing. So, we give you the curve. Here it is. Just plug it in the formula right away. Nothing really to think here. Solution. Just the whole point is to remember the formula. Unfortunately, that requires some memorization. Length in polar is the integral from alpha to beta, well as given from 0 to pi over 3. Very nice. It's always a gigantic square root, so at least put there, don't forget. Now in parametric, so okay, let's see, we have 3 formulas now. Oh, maybe let's review all 3. How about that? What was the first formula of L we learned? From A to B, I remember there was a gigantic square root, then what? 1 plus derivative squared. Amazing. And it was dx or dy, depending on how it was given. Good job. You see, someone remembers that was like a month ago. Then parametric. So this formula was exam 2. Exam 3 was using parametrics. Formula in parametrics was from A to B. Again, a gigantic square root. Derivative squared. Now x was its own function. And y was its own function. So I like to say out loud, derivative squared plus derivative squared. That gives me some kind of mnemonic way to memorize it. If I whisper to myself, I remember the formula. And now there's a third one. The third one is, we just got it right now. Original squared plus derivative squared. So let's write it down. This one is Cartesian, parametric, polar. Polar. And polar is original squared plus derivative squared, d theta. From alpha to beta, d theta. That, well, I guess let me write down. From alpha to beta. That is the formula in polar. Whoever is talking will be just solving right now the integral for me. I can hear it. So prepare. L equals from 0 to pi over 3, that's given. R squared. Just take the original 3 sine theta and square it. plus. Okay, who are you guys talking? I know that. What is derivative squared will be? See, you need to pay attention. So we have r squared plus derivative squared. So what is derivative squared? Well, what are we talking about? Okay, then please pay attention. Derivative squared is r, and I'm differentiating 3 sine theta. Derivative of 3 sine will be 3 cosine theta. And you're squaring that. The blue part is derivative d theta. Interestingly, so I put it on the test, and if you forgot the derivative, for example, of cosine is negative, doesn't matter because it's all squared, so you will not make a mistake there. And it's very nice. So this is just one more thing to memorize, unfortunately. But at least it's actually not too bad. So again, original squared, derivative squared. And by original, I'm talking about the function. So let me put it in green. The function r. R depends on theta. Questions about how we build the formula? Now I will ask you to actually solve it. Let's do it. Luckily, that's the best integral ever to have. That's like a dream integral. Why? Who can tell me why? Sine square plus cosine square is 1, and then times 9. 9 sine square plus 9 cosine square gives you 9 d theta. Now, very interesting. If you don't have variable inside, the answer will be square root of 9, which is 3, times the length of the interval pi over 3 minus 0. Or you can actually solve it. It will be theta plus pi over 3 and 0 gives you pi over 3 minus 0. So it is just pi. The length of this curve is just pi, which is 3, 14, 59, blah, 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 blah. So it is some number, pi units. Here's a picture for you. The graph is a shifted circle, and we asked to find, not the whole thing, we were asked to find the angle 0, and then remember the angle alpha, this angle, for example, beta, is we're gonna put the point, and we want to know the angle, the point that has the angle with positive x-axis to be pi over 3. So when I found the second point, now I know I'm looking for the length of this curve. And we found it. How long is this curve? It is pi long. That's what it means. So the first angle, alpha, is 0. The second one is pi over 3. That's how you find. Not too bad. What do you think about this? So that's something I don't plan to put too much attention because very straightforward, nothing to actually calculate here, nothing to create originally. Put in the integral, integrate. And it's already in the test, one multiple choice problem. Let's see if we want to do more. I guess, well, let's do one more homework problem, why not? Let's do a quick one. Example 2. How about if r is given 10e to the minus theta? 10e to the minus theta. Find arc lengths 4. And then it should be somewhere from 2, or else it's infinite. Whatever this graph is, which actually I can figure out. What is it? 10e to the minus theta. If I go to my favorite wall from alpha and plot it, we're gonna see what it looks. R equals 10e to the minus theta. If you type theta, it knows what it is. It says, is it what you want? I'm checking, yes. Okay, it looks like that. It's a spiral. Let us keep unspiraling. So it starts here, and then it's unfolding. But it's infinite. That's why it should be given some kind of information. How long do we want to track it down? And it says we want to keep tracking from 7 over 6 pi, 7 over 6 pi for theta, and 8 pi. Again, your job is to remember the formula. Honestly speaking, it's hard to memorize formulas. So what I did as a student, because I don't have good memory. When the exam starts, before starting the test, I would write down all the formulas I know for the exam. So I would write down that until I forgot. And then you can actually forget it because now it's written. That's a very good idea. If you write it down when the exam starts from your brain, you just release it. Just like put it there in front of you somewhere. Solution. So it's kind of like more talking than actually doing stuff. From 6 pi to 8 pi, gigantic square root, and now we have three formulas. You just think about which one it is. 1 plus derivative squared, no. Derivative squared plus derivative squared, no. It's original squared plus derivative squared. So I will have 10 e to the minus theta squared plus 10 e to the minus theta squared. Tell me if it's correct or not. What do you think? Correct or not? Why did I just copy both? Well, you take derivative of r. Derivative of r is minus 10 e to the minus theta. And so, derivative, right? Derivative have chain rule. Copy e and multiply by the derivative of the function inside. Derivative of minus theta is negative. However, if you made this mistake, nobody cares, it's squared. But if you made mistake and there's like a 5 inside, then you have to multiply by 5. That will be pretty important. But in this case, it's very convenient because then you just have those two added together, 7 over 6 pi, 8 pi, a square root. You have just double of the same thing, which is 2 of 100 e to what? How do I put down this 2? Do you know? Negative 2, exactly. Negative 2 theta. You multiply d theta. Again, it's amazing integral to have because I can actually kick out the constant 200s. Let's keep it 200s outside of the integral. And then the square root undoes the 2 because square root is raising to 1/2. And you end up with e to the minus theta d theta. Some function like this already on a test for you to practice U substitution. This is U substitution. Minus theta have to be u, find du, blah, blah, blah. There's a U substitution shortcut, which I personally like a lot, which gives you what? What is the integral of e to the minus theta? Copy, divide by the leading coefficient. That's U sub shortcut, or perform U substitution. We will review it later for you if you want. Bar 7, 6 pi, 8 pi, and you plug it in and you get a number. Square root of 200, by the way, square root of 100 is 10. So it's going to be 10 square root of 2. 10 square root of 2. Minus in front. And now it's kind of suspicious. The arc length should not be negative, right? So that means this product, top minus bottom, better be negative. E to the minus 8 pi minus e to the minus 7, 6 pi. But e to the minus input is decreasing. So the smaller number you plug, the higher it is. So it is negative. So it should be fine. You can also calculate the approximate number and it will give you a negative number. Not everywhere. I mean, this should be negative. Do you know why it matters? Because the negative sign in front means something multiplied here should be also negative in order for everything to be positive. It is arc length, okay? It's arc length, so it's better be positive. That's it. I don't want to simplify this. So that's what we need you to do. Basically, practice U substitution, practice integration. Last chapter also has lots of integrals to practice for the final exam.